Okay, hey there, boys and girls. 'Tis I, your illustrious teacher, stepping in for the 6'5" group of guys who are a bit shy about this sort of thing, I guess. Anyway, I think it is helpful to have a little bit of description as you go through this PowerPoint, so I'm going to do that. They are working on an example from our text that will be about fitting data to two models, linear and quadratic, and we're emphasizing the quadratic. That's the parabolic shape of a curve to fitting data. So we have an example from page 359 that talks about a glider, and as the angle of the wings tilt, as the glider tilts its wings, it'll make a loop. It'll curve around in a bank, and it drops in one full circle a certain amount of feet. So you can see here is the angle of the glider wings, and there's the height loss after a 360-degree circle. So it loses quite a bit of altitude at 20 degrees, and then it loses a little bit less and less and less each time, and actually between 45 and 50 it loses less angle. So there's a bit of a aeronautical paradox there, but that's not the point of this question. What is the point is that we're going to graph that, and we're going to see, is it better graphed as a parabola, as a quadratic, or is it better graphed as a line? So you can take those data points and you can plot them. We've just got a table here. If you want to look on the page in the book, they've also graphed it for you there, so you don't need to redo it. But here is the angle, and there's the height, and then we're going to compare it later to a line and to a quadratic model, and we'll see the deviation right here, how much it's off by our prediction, and then we're going to square those deviations, and that gives us a standardized way of comparing whether a line or a curve is a better fit. So to find the best fit line, you do this on your calculator. You can use a median line without a calculator, but the only way we can do it right now for a linear regression is on your calculator. All right. So you type that into L1, you type the data into L2, you do quadratic, or sorry, you do LinReg, AX plus B form, that's like Y equals MX plus B form, and you get the slope of negative 1.16 and a y-intercept of 121.6. Okay, and then you can, using your trace mode, you can just enter the x values in, and it'll spit out the predicted, according to this equation, y values. And when you do that and you type those all in, you'll get these values here. Okay, that's what you're expecting. You can compare that to the actual amounts here, and they're close, but they're not exact. You can then subtract each of these and find the deviations, and then you can square each of those numbers, and there you get the deviation squared. So you can see, like, our equation predicts 98.4, but really in a real glider it was 108. You subtract those two, you square them, you get all these amounts. Notice these are all positive, and notice also that it's a little bit like the quadratic formula, and this is where we get our least squares from what's called the least squares regression line, is that we're squaring all these numbers and we're trying to minimize that amount. The more deviation, the worse it is. So you add them all up and you get a total of your least squares, or your deviation squares, is 250.12. That's for the straight line. Well, if we do the same thing with a quadratic regression, quadratic, on our calculator, this is what you get. You get the A as being 0.068, you get the B as being negative 5.9, you get the C as being plus 198. And when you do the same thing with our chart and you fill in, you see the deviations here are actually much, much smaller. So right off the bat we have a suspicion, strong suspicion, that it's a better fit. When we do the deviations there, we square them, you'll see that even the largest one is still way smaller than the other graph. Now when we add them all up, we get the sum of those deviations is 11.4, which is far less than 250. Therefore, we can conclude that the curved line is the best fit. All right. So in some of your homework, you will be typing in the data. You will be coming up with a quadratic regression. You'll be looking at the curve and deciding if is it more like a curve or more like a straight line. And one way you can put a numerical value to it is by finding the deviations and squaring them and adding them all up and seeing which number is the smaller number. Smaller is better when it comes to deviation. Alright, thank you guys. All done.